Okay guys, in this case we need to calculate the amount of grams of iron oxide that would be formed when we burn 8 grams of iron. So the first thing that we need to do is to write down the equation and balance the equation. So in this case it's going to be iron plus oxygen. That gives me iron oxide. So we need to calculate to balance this. We have 3 oxygens here. We're going to put a 2 in front of that formula, indicating that we have 2 moles of oxide. And since these 2 affects also the oxygen, we need a 3 here to have 6 oxygens in this side and 6 oxygens in this side, and a 4 in front of the iron, because these 2 affect both of the irons that we have here, so we have 4 in both sides. Now we need to calculate the masses. For calculating the masses, we need to know the atomic mass of iron, which is going to be 56, and the atomic mass of oxygen is 16. So we can calculate the mass of the iron. 4 times 56 is going to be 224. That is the mass of iron that reacts. 224 grams, plus 3 times the molecule of oxygen. Oxygen is 16 times 2 is 32, and we have the molecules 3 times, so we have 96 grams of oxygen. That is going to give me iron 2 times, so it's 56 times 2. This is 112, and oxygen is 16 times 3 is 48. That makes 160 in total, but we have 2 times that, so it's going to be 320 grams of oxygen of iron oxide. So this is the first part, balancing the equation, calculating the masses. Just in case, double check that the masses on the reactants is the same as the masses in the products. We know that this is correct. And now we can write down the question in the form of fractions. So x, which is the thing that we need to calculate, is going to be grams of iron oxide how many grams of iron oxide will be obtained with 8 grams of iron, and we will get the information from here, from our equation. So grams of iron oxide and grams of iron, and now we will take the information from the equation. Grams of iron oxide are these ones that are here, and the grams of iron that we need here are going to be underneath the iron. So we need to write down the numbers, 320 in this case, and iron 224. So x will be the same as, we can cancel this, grams of iron and grams of iron, okay, and our x will be the same as 8 times 320 grams of iron oxide divided by 224. This gives me a number that is 11.42857 and so forth. Okay, now how many decimals do we use? How many significant figures we are going to use in our answer? Of course, these are gram of iron oxide. We need to see how many significant figures we have in this case. We have two two zeros after the decimal point means that they are significant. So it has to be with three significant figures. So how many significant figures do we need to show here? Three. 1, 2, and 3. And basically, since the next number that is here is a 2, we are going to leave the answer like that. So X will be 11.4 grams of iron oxide. In this case, this is going to be our answer. Now, one thing that we didn't talk about is what happens when we really burn the iron, the 8 grams of iron, and we don't get this number. Let's pretend that instead of 11.4 grams, we only obtain 10 grams. So in the lab, we obtain 10 grams of iron oxide. So what happened? What happened with the 1.4 grams that were not obtained? Actually, what we obtain with the calculations is what we call a theoretical yield. Theoretical yield. That is what we are going to obtain in ideal conditions. But we always have a loss of mass somehow, or we did any mistakes, or maybe the conditions of the reactions are not the necessary, the ones that we need to make that theoretical yield completely to take place. So we, instead of 11.4, we got 10 grams. So we need to calculate which is the percentage that we got. So our theoretical yield is always the maximum amount that we can get. So that is going to be 100%. So 11.4 grams of iron oxide are going to be 100%. But we didn't obtain that. We obtained 10 grams of iron oxide. We are going to calculate how much is the percentage. So the percentage is going to be 10 divided by 11.4 times 100. And that is going to be equals to